Good morning, children. Today we are going to know the chemicals obtained from brine solution or salt solution. Brine solution is nothing but concentrated solution of salt, common salt. Okay, generally the sea water is known as what we call it a brine solution. Concentrated solution of common salt is known as, or aqueous solution of common salt is known as what we call it brine solution. We call it as the brine solution. So what are the important products that are obtained from brine solution? Electrolysis of brine solution or common salt solution, concentrated salt solution gives so many compounds which are useful in our daily life. So this process is known as what we call it a chloro-alkali process. What we call it a chloro-alkali process. When current is passed through the brine solution, it gives alkali and chlorine and hydrogen. Chloro means chlorine gas and alkali means a base. A base is obtained and chlorine gas is liberated. At the same time hydrogen gas is also liberated. Are you clear about that? So electrolysis of brine solution gives three products. One is what is the first one? Sodium hydroxide. It is an alkali. Next one, the second one is the chlorine. The third one is the hydrogen. So it is known as chloro-alkali process. Chloro-alkali process. So what are the materials needed for this one? I have taken distilled water. And this is common salt. See this one, crystal salt, common salt. Next I am preparing the common salt solution, concentrated salt solution. See this one. See this, I am preparing the concentrated salt solution. Part of the salt solution, concentrated salt solution, this is known as brine solution. Next one, the next one is two electrodes. Generally they are made up of graphite. I have taken pencil leads. These are the two electrodes and the connecting wires. And the next one is, see this one, this is 5 volts battery. See this, what I am doing. Now I connected the two graphite rods to the 5 volts battery. The graphite rod which is connected to positive terminal is known as anode, which is connected to negative terminal of the battery is known as cathode. Now what I am doing, I am passing the electricity through the brine solution. Observe the changes that are taking place. Observe this. Some gases are bubbling out. Observe this carefully. Some gases are bubbling out. Okay, some gases are bubbling out. Observe this carefully. At cathode, at anode, observe, do you find any gases? Bubbles are formed. Observe this carefully. Two gases are generated. What are the two gases? One gas is chlorine. Another gas is, what is that? Another gas is hydrogen. But at the same time, sodium hydroxide is also formed in this reaction. Let us wait for the reaction to take place. So what I am doing, I am passing the current through the concentrated solution of salt, or which is known as the brine solution. Observe this one. Now you will find more bubbles. Can you find the bubbles? Do you find the bubbles here? Okay, so those bubbles are nothing but two gases. One gas is hydrogen, another gas is chlorine. See this. Let this process go on continuing. See this one. This is phenolphthalein indicator. See, phenolphthalein indicator stands to pink in the presence of basic medium. Just what I am doing, I am adding few drops of phenolphthalein to that solution. The process is going on. Observe this one. So gases are still evolving. I am adding 1 or 2 drops of phenolphthalein. See this one. See this. This is an indicator. Phenolphthalein turns to pink in the presence of basic medium. Observe this one, I am adding phenolphthalein drops. Observe this one. Do you find the change? What is the color? Pink color. Do you find the change? So, means a base is formed. A base is formed in this reaction. So, altogether how many products are formed? 3 products are formed. One is the hydrogen gas, another one is the chlorine gas, another one is the base, which is nothing but sodium hydroxide. What is that base? Sodium hydroxide. See this one. Do you find the pink color? Do you find the pink color? So, this process is known as, can you see this? This process is known as chloro-alkali process. Chloro-alkali process. So, chlorine is liberated and alkali means a base. Water soluble base is known as alkali. A base is liberated. A base is produced in this reaction. That's why it is known as chloro-alkali process. Now, write down the chemical reaction that is taking place. See this one. Here I am writing the balanced equation. First I have taken salt solution NaCl plus water. I am passing the electricity. So you will get sodium hydroxide plus chlorine and hydrogen. Chlorine and hydrogen. See this one. Is it a balanced equation? See this one. See, I am multiplying with 2. Now, see this one. 2. Is it balanced? Look carefully. 2 sodiums, 2 sodiums. 2 chlorines, 2 chlorines. 2 hydrogens. Here, next one. See this one. Here, 2 hydrogens plus 2 hydrogens. 4 hydrogens. But here you multiply again with 2. 2 to the 4 hydrogens, 2 oxygens. Here 2 oxygens. Now it is the balanced equation. See this one. 2 hydrogens. 2 plus 2, 4 hydrogens. 2 to the 4 hydrogens. 2 oxygens. 2 1 ja 2, 2 oxygens. 2 sodiums. 2 sodiums. Okay. 2 chlorines. Okay. 2 chlorines. Now it is a balanced equation. Now hydrogen and sodium hydroxide, these two are formed at cathode. They are formed at cathode. Next, whereas chlorine is formed at anode. At anode. At anode. So anode chlorine gas is formed. Are you clear about that one? So this process is known as what we call it chloro-alkali process. Next, what are the uses of sodium hydroxide? Uses of sodium hydroxide. Used in preparation of soaps and detergents. Next, second one as a, see it is given, see this one, uses of to metals. Next, the third one is in paper making, paper industry. And in making artificial fibers. Okay. Next, chlorine. It is used in the treatment of water. Okay. To kill the bacteria present in water. Are you clear? Next, in making pesticides, we use chlorine. Are you clear? Next one, hydrogen is used in the hydrogenation of oils. As a fuel also, hydrogen is used. See this one, look into your textbook. It is given in your textbook, page number 55. See this diagram. See this. This is the industrial diagram. Okay, how this chloro-alkali process goes on. Are you clear? Thank you.